our last session of the day, which is on decarbonizing for a sustainable digital future. I welcome everybody in this panel and on this session today evening. I would like to welcome our panel who have been gathered here who are willing to share their insights about today's sessions. Starting with our first panelist, Rashim Kapoor, EVP Network Mobility, Bharti Airtel. Kindly join us on the stage, sir, with a great applause. Following, I would request Payal Mittal, ma'am, DGM from MTNL. Kindly join us on the stage, please. I would request Magnus Everbring, CTO APAC Ericsson. Kindly join us on the stage, sir. Thank you. I would also request Dodu Sam, Technical Director, Pros Technologies. Kindly join us on the stage, sir. Namrita Rana ma'am, National Head of ESG, will be joining us as a moderator for today's session.
Thank you very much. It's wonderful to be here today and to talk about decarbonizing the telecom sector. And why do we need to decarbonize? We don't really see smoke coming out of chimneys in the telecom sector. It is considered to be a very clean sector. But why do we need to decarbonize? What does it really mean to all these stalwarts here with me on the panel? I'd like to just invite everybody to give their quick thoughts on what decarbonization really means to them. Rashim, would you like to begin?
Yeah, hi. So I will like to start what decarbonization means for Airtel. So in Airtel, sustainability is one of the key, I would say, business strategy. We were the first telco, Indian telco, to be part of the global corporates to take the pledge on science-based targets on the way towards achieving 1.5 degree centigrade pathways. We have done significant steps. We are committed that we will reduce our carbon footprint by 100% by 2050, with a milestone of 50% by 2030. In that respect, we have taken some of the internal targets on sustainability. So greening the network is our topmost priority. Second target which we have taken is climate proofing, because if you don't climate proof, when there is a natural calamity, then power available is zero. And if the power is zero, you use fossil fuels, which will lead to more decarbonizations, or I would say more emissions would come in that respect. And third is waste management, which is a very important subject for us because we use a lot of fossil fuels. So how you do a proper waste management is also one of the key pillars of our overall decarbonization strategy. The easier way to handle are the data centers. So data centers, we are committed to REL 100 standards, RE 100 standards. By 2027, we commit around 70% of our consumption will come from green energy. And we want to be 100% green energy on our data centers and MSC locations by 2030. So these are a few of the key initiatives we have taken. We are also using a lot of modern technology to reduce carbon emission. People believe that the 5G radios consume more power than the 4G radios, but as per us, the kind of technologies which we are buying and the kind of AML technologies we are using, if we have to calculate on per GB per watt basis, the new radios are consuming 5x less power as compared to the older radios. Similar things we are doing in other technologies, like in core networks. A single server used to generate, say, X Gbps. Now the same server is able to generate 10x Gbps by more efficient softwares, and the power consumptions are same. So a lot of initiatives are being done to green our data centers through using the open access green policy or using the captive plants are some of the other initiatives we are taking.
Good evening to all. First of all, I want to tell you that I am here in the capacity of a research scholar. Decarbonizing in ICT industry is one of the research topics I'm working on. So for me, the important thing which I want to say, as we shifted from 4G to 5G, Although the equipment has become more energy efficient, as he just said, but the part is the higher number of bits moving through a 5G system leads to a many-fold increase in the energy consumption. So we need to work heavily towards decarbonization because we are consuming too much energy into the system. And as the technology upgrades, the energy consumption is likely to increase. So we just have only a few choices. One is like we take a digital sannyas, which is actually not possible as of now. We are so much dependent on technology. So the other is we use the technology to get back into the system and decrease the consumption of energy wherever is possible. We can dynamically control, this is what is digital sustainability. We can control the energy which is being used in the system, in the network. So for me, like I have worked on a few things, and digital sustainability, for example, we can have data center efficiencies, things like green cloud computing and all, which can help us to reduce our carbon footprints. There's one more thing like we can do, and maybe the operators can tell me how much are they depending on the renewable energy which is being used for the systems right now. Because right now, most of the dependency, what I see, is on fossil fuels, which means the decarbonization, the carbon footprints we are leaving behind, the greenhouse gas emissions are very high. So the system has to or should shift over to renewable energy a bit. I think so.
Thank you so much, Payal. That was really interesting. Magnus, it would be lovely to hear from you as well on what decarbonization means to you and your organization.
Thank you, and good evening, everyone. So decarbonization, first of all, I should say, as we as individuals, corporations, organizations, of course, it's a profound responsibility to make sure that we drive this area seriously and over time. Now, representing Ericsson, so what can we do there? I think of three levels. One is, of course, how we as a company work and operate. And that is really end-to-end. That includes how we source, how we supply, how things are being manufactured as components and brought to us, and how we assemble it and then bring it to our customers. And there, naturally, we have carbon net zero goals 2040, minus 90% by 2030 as examples. Second layer or avenue then is the products we produce and we then supply to our customers. And these products and also how they are being assembled into systems. They need to ever improve, making sure that the footprint, carbon reduction is there as they are being deployed into the field. We heard here statistics from 5G equipment. It's an extremely potent technology, and it will carry ever more load from the users. It's wanted, if I put it that way. And loading it more, of course, makes it more efficient. It's the most efficient technology. And this we try to meet up by making sure we're really at the edge of what technology can deliver. Our experience is clear there. To deploy that on a massive scale, overall on a system level, gives the most efficient footprint in terms of environment impact. And then the third avenue, in a way perhaps most exciting, and that's how digitalization, thanks to or through the mobile systems, drives the carbon footprint overall in society. And here, of course, the impact is profound. We have many good examples coming now how industry is digitalized and becoming data-driven. They can optimize their operations and become considerably more efficient. Here we are only at the beginning of a long journey. We have a challenge in driving the implementation, scale, upskilling, driving the ecosystem. But over time, that will give a big effect on all of society.
Thank you so much. Tiru, Sam, would you like to contribute to the discussion as well?
Hello? Yeah, I mean, first of all, it's great to be here. And when we talk about decarbonizing, so actually it's one of our area of expertise because we are responsible of the antenna systems itself. And when we talk about antenna systems, so it's the hardware that is responsible of sending and receiving signals over the air. So, which means we are taking three main points to deal with decarbonizing, which means when we are emitting signals over the air, so we have seen that the existing systems is only able to transmit between 65 to 75% of the input power. So this means that there is at least 30% or 35% of power that is being wasted throughout the space. And this goes mainly to the area below the coverage that is impacting more the electromagnetic interferences. And the other area goes over the sky that is causing also interference within those low altitude drone communication. And when emitting power itself, so there is also a CO2 that is being emitted over the air, which is also impacting the environment and our also social life. So the second point is lies mainly on the lifetime itself, because more CO2 reduces also the lifetime or the life cycle of the hardware itself, which you have invested a lot of money, and by the time you exploit it in a full way, so you will realize that the performance itself degrades. So, and this also motivates us for the past few years also to bring into the industry and also try to drive the standard into reducing the power consumption from, I mean, because the communication system is end-to-end solution. So, but for every single component, there is a room at least to deal with useful energy and try to convert the wasted part of the power into useful one so that we can have less emission of CO2 that goes over there. So, thank you.
Thank you so much. So we've heard from our experts that there is many definitions to decarbonization. But fundamentally, it's just about reducing carbon emissions, reduction, recycling, and just looking at things in a deeper way. But how can we actually make a difference to the world around us? The telecom sector is a massive sector that actually functions on the basis of the electronic grid. The electronic grid is the largest man-made thing on earth. The second largest man-made thing on earth is the telecom infrastructure that we have. And both these things need each other to function on. Post-COVID, the amount of digitization that we have seen and the acceleration towards technology, we are only going to increase our usage of technology. And to Payal's point, can we take digital sannyas? Can we just stop looking at our phones? I'm not sure that's really possible because we are all so connected. And in this connected world, what is really the answer? Is the answer to stop using technology, use more of technology, use AI, but then AI also is a massive energy hog. So while you can optimize many things, you can improve processes, our hunger for telecom sector as a whole and our need to stay connected will only lead to an increase in emissions. I want to pose this question to all of you, and Magnus, as one of the largest telecom operators, what do you think is the answer and what more needs to be done at a global level?
Okay, now we go. Okay, thank you. That's a big question. Okay. top of my head. I mentioned before, how can mobile systems, the telecom segment, assist and help the rest of society? So let me give a simple example. And we have, of course, factories all over the world. We've had them for whatever, 150, 200 years. And they're well operational, right? It's okay. But now when we digitalize, new insights will come. And that will drive innovation in many ways. And few examples then of what we've seen. So we started in our research group 10 years ago, almost 2015, a program called 5G for Industries. We didn't have 5G, but we sent our researchers out to certain industries. Reason was not to educate them on 5G, but rather on how to cut the wire, if you wish. And perhaps most importantly, for them to understand how does a factory work. One factory was a mine. Right? It's a kind of factory. It's just 400 meters below the level of ground. And then these are big mines. You drive around in cars and so on. First thing they did was to take the top-notch then 4G system and install it into the mine. The people working there, they were a bit blown away. Of course, they could now make phone calls and talk and quickly resolve things. Okay, fine. Second thing was that they could use their laptops and pads. And the speed of that system was better than the office lawn. And then creativity started to flow. And here I'm coming to the efficiency and green factor. So in the mine, as I said, you drive there with cars, you have fumes from explosions which are toxic, etc. So you have ventilation. You're forcing air into the mine all the time. If you, as a worker in the mine, feel maybe the air quality isn't all that good, they have sensors every bit here and where. Then you stop your car, jump out, and you push a big red button on the wall. And then the fans go up in high rev, and you force air into the entire mine. Okay? Then our people looked at this, and the sensors they have to measure the air quality, they were connected with a wire. And they had relatively few of them. Why is that? The labor cost of deploying the sensors. You need to pull the wire. You can imagine in a mine, when you've done that, all of a sudden you decide to blow a new tunnel and you have to rewire. So, not a very bright idea, right? or not a very complicated idea, but bright idea I should say, was to just put in an IoT device with a sensor. And then all you had to do was to supply it with a battery and just glue it to the wall. And then the cost of having many sensors went drastically down. So they did that. And as a consequence, people working in the mine knew that the air quality was better monitored, and they pushed the red button considerably less. Just managing the thought process of the people working there. And of course, in reality, having a better measurement also. From an energy point of view, what's the catch here? Well, when you push down air into a mine, you have to lift out air, right? Otherwise, there's no space to put the fresh air in. It's a closed cavity. The weight of the air that they lifted out of the mine with the fans weighted more than the actual ore that they retrieved from the mine. You can imagine the electricity bill that the mine had before having more sensors. And I can show you, nobody thought about this before they started. You have to be in there, in the factory, and see, now we can take this step, now we can do this, and then you start to reap the benefits.
That was an amazing example where better communication and the ability to use technology in an innovative way helped you increase efficiencies, improve processes, and there was dramatic change that could be seen. Didu Sam, do you also have a similar example where, technology can work as an enabler and the telecom infrastructure can then help society in a fundamentally different way?
Yeah, exactly. And I will go straight forward to a very practical scenario. So, where from design viewpoint, so for every single component, so in my research group right now, there is a requirement that you have to think for the environment before you start. And this helped us also to release one very innovative product that helped the network operator to be able to reduce between 15 to 20% of the transmitting power that goes into space. So what does this mean? So this means there is only at least 10% of power that is being wasted. So which means there's less impact on the environment. Of course, the goal is to go 0%, which is quite challenging, but in a good way. So this is the first result that we came out in the industry. And the second one is we have come up proposing some new material technology and processing that can be easily recycled into something else that are having, let's say, a low loss and quite easy to design some new form factors that has less weight impact. So, and this help at least to have, let's say, 15 to 30% of CO2 emissions, so which is still contributing into the environment. And so the next good thing is that the existing material that was used, if you install this hardware outdoor, they are not supposed to be there under ambient temperature. So we're talking about 22 plus minus 3 degrees Celsius. So the temperature goes from minus 45 degrees Celsius all the way to 65 degrees Celsius, and it's continuously, so which will also impact the material itself, that will lead to some corrosions that may also reduce the lifetime of this one. So which means now practically we can make sure that at least it's going to be there 10 years. Even theoretically, the lifetime is like 200 years, but this also results on, let's say, having an ambient temperature which is quasi impossible to have in real deployment scenario. So if I can summarize all those points, so basically, so we're thinking into giving opportunity to the operator to think about using some renewable energy sources, because this could help at least to have some solar panel, for example, with some low power, because you can still compensate this loss from the hardware, for example, a couple of 3 dB losses, so that it would be very easy to embed some solar power outdoor, sitting on a hardware that is giving you, let's say, part of the energy sources that goes into your transmitter systems. So, thank you.
Thank you so much. Payal, you from an MTNL point of view, and Rashim, you from an Airtel point of view, would have seen very closely how Indian growth has accelerated. And we've been talking about the Viksit Bharat program of India. Yet at the same time, we are also seeing India's decarbonization goals. And the telecom sector is important to both these things. How do you grow while decarbonizing? What are the challenges? What are the opportunities? And how do we actually significantly transform our industry and sector to actually contribute to both these aspects? Whichever one of you would like to go first. Payal, would you? Okay.
See, as part of my research, what I feel one greatest challenge we have is the disposal of the hardware. We are producing huge amount of e-waste whenever we switch over technologies, as we upgrade to new technologies. And I feel some of the companies are doing their bit by letting you exchange old equipment whenever you upgrade to a new one. And they are able to use the old hardware wherever they can. But we are generating a lot of e-waste. And that is a problem, that is a challenge which I feel we all have to address to. Because disposal of that e-waste is again going to generate more greenhouse gases. You want to say something?
Yeah, so as rightly mentioned, India, there is a lot of data growth which is happening. If I have to give some numbers, from 4G to 5G, the data consumption per sub has increased 3x. Using fixed wireless access, it is 10x. And once we start launching millimeter wave, it can be even 100x. India per sub consumption is highest globally, whether we talk about developed markets or developing market, we are few x higher than anybody else globally. Having said this, on the initiative which we are taking is one by using AI as a technology. See, the networks are built on busy hours, but the consumption is varies. A busy hour consumption and a low peak hour consumption, there may be a variation of 70-80%, but energy consumption may be same if nothing is done. So what we have been doing is seeing the traffic distribution pattern during the day, traffic distribution pattern from home to office locations. For example, a cyber hub will have a different kind of, or Knot place will have a different kind of traffic patterns during day, and evening the home location will have a different kind of patterns. So do a effective traffic engineering and using only the, say, coverage layer, not the capacity layers during off-peak hours is one of the things which has helped us a lot. Similarly, using AI technology while network planning, we always error in over-dimensioning the network if not predicted properly. So using the AI technology by proper planning of network so that we induce and deploy less electronics has been the second thing which we have been doing. Third, we have been working very closely with engineering teams of Nokia, Ericsson and other OEM providers to have software more efficient. We have seen that software are still not able to use the complete compute power. So how we can use more GBs out of the same server or same radio unit is a big initiative. On renewable energy, as I said, on data centers, we have been able to make good progress and we are committed with zero emissions very soon by 2030. We are using some captive plants, we are using a lot of solar, we are able to store the renewable energy at our data centers, but challenges on radio sites. Now these radio sites, though they generate only 4-5 kilowatt of power, but they would be 3 lakh or 4 lakh in numbers. And here, though we have started solar, we are already doing around 25,000 sites on solar. We have a plan, but ultimately, if this is not solved, we will not be able to solve the decarbonization for the telco sector. We would need some help. I think storage of renewable energy has been a challenge, and this is one area where some innovation should happen. Ultimately, if we are using lithium-ion batteries to store the battery, it is again leading to more e-waste. So we are helping on decarbonization, but e-waste would increase, so that is not helping. Second, on policy, there are policies available from government on open green access, where you are able to have a renewable energy and then you can offset, but that is applicable for the places where it is more than 100 kilowatt. Cell side, which is 5 kilowatt, I believe there has to be some initiative where we can aggregate this power of a district or a location and then produce renewable energy and offset that. I think that is one thing would definitely move a needle. Otherwise, there will be some baby steps on technology or some baby steps on doing some part of solar.
Thank you so much, Rashim. In the interest of time, I'll just like to close the panel with some closing remarks. What I really learned from everybody is that decarbonization is way more than just looking at energy. It's about looking at things in a systems approach, which basically means everybody needs to work together. So not only do we need to look at emissions during the utilization of the telecom infrastructure, we need to look at overall reduction of e-waste. We also need to look at how the telecom sector is contributing to overall growth, but also decarbonizing other industries and other sectors. And there were some wonderful examples given by our panelists today. And I'd like to invite all of you to think more, think deeper, think longer, to say how do we balance out the challenges of growth and decarbonization. So ultimately, to me, decarbonization is really about balance, the balance of society, balance of life, balance of the industry, and the fact that telecom is such a fundamental part of our lives. So if we can manage to decarbonize the telecom sector, I think we have a lot of hope in decarbonizing other sectors, other industries, and even other countries. Thank you all very much for your time this evening. I'm conscious of the fact that this was the last panel, and I'm really grateful to everybody for coming in and to the audience as well. Thank you.
Thank you, Namrita ma'am. Thank you all the panels. I think we definitely agree that it's all about the balance of telecommunications, balance of life. So thank you all for shedding light on this topic, and I think we've all, with your expertise, we've enriched this conversation. I would request moderator ma'am to kindly distribute the mementos with our panelists. Kindly, big round of applause, please. Payal Mittal ma'am, research and scholar, Green Energy Technologies. Magnus Everbring. Thank you so much, sir, for joining us on the panel tonight. Thank you, Dudu Sam, for joining us and shedding light on this profound agenda today. I would also like to appreciate Amrita Rana ma'am and give our token of appreciation.